Okay, let's go and get started today. Today we're going to be doing class 3. We're going to get started in some actual programming stuff today. And there's going to be a lab for you to work on as well. So watch for that. All right, let's go and get started. So first thing, overview of what we're going to cover today. We're going to look at how to use Python in shell mode, how to use Python in script mode where you can actually write programs. And then we're going to look at some simple Python commands and start building up our vocabulary of those. So let's go ahead and get started with that. All right, so the first thing is Python, you can run it in shell mode, which gives you this interactive session with the interpreter. And that allows you to type things in and immediately get some response. Or in other words, you'll type in a line when you hit enter, that'll pass that to the Python interpreter, which is, again, just a program that kind of converts that into actions that the CPU takes. And then it's going to immediately take an action, and we're going to see some result from that action. So, for example, here we type in print and then hello there in quotes or in these parentheses. And the interpreter will say, okay, they give me a whole line. I will convert it into what the machine needs to do to make that happen. And then hello there will pop out on the screen. So it'll immediately take an action. And the advantage of that shell is it allows us to do things kind of interactively and type something in and see what it does. So it's really useful for experimenting with things, for trying things. It's also really useful to use that as a calculator. And in fact, that Windows calculator thing that comes with Windows that you bring up and you click the buttons and it does things, I really haven't used that for many years because I always go to Python. And Python lets you just type in expressions. It'll calculate it, give you an answer. You can do more complicated things with the shell as well. But it's the interactive nature of that that makes it really useful. Okay, so shell mode lets us test things out or use Python as a calculator. And you'll type something, you'll always get a response. Now, if you type something wrong, it'll give you a response saying you made a mistake, but you'll always get some response back from that. All right, so let's switch to the interpreter just quickly here and look at some examples. So let me go ahead and pull up idle here. And let me switch this over so we can see that. Okay, so let me turn that on, turn that off, and let me grab that. And actually here, that's not working right, so I need to switch it just to do a display capture. Okay, so here's the actual display. Let me move this so we have a little bit larger font size, and let me move it so that it's on the screen here. I'll put it right there. And let me change the font size, so let's just do 22, apply, okay. All right, so now you should be able to see that on the screen here. So quickly looking at this Python shell, the way that we have it right now, is you'll notice that, let me make this a little bit bigger here. So notice if I type print, hello there, it immediately takes that action. But notice we can do some other things with this as well. So notice, for example, I could say print 10 times 246. And it will compute that for us and print out that answer. Notice if I don't want to use print, I could just say 10 times 246, which we could do in our head, but we'll do it that way. And notice it'll still give me the answer back if I just type it in. Once we get into script mode, though, we're going to want to use print if we want something displayed. The Python shell will kind of display the result of something anyway, even if we didn't use print. But when we get to program mode, you're going to want to use print when you want things displayed. It won't display things unless we use print. Now in the shell, it will. Now, notice that we could do fairly complicated things here as well. So for example, if I wanted to calculate something like something to do with a circle, I could say, okay, pi 3.141592653. So pi times, and let's say a radius is like 100, and then we want that to be squared. So we'll just do 100 times 100 here to square it. And notice it will calculate that result for us. The other thing to note about the kind of this Python shell is it will always take it. Now notice if I make a mistake and I were to say print and then say hello there without putting it in quotes, it'll say that it's a syntax error. It doesn't understand what hello space there means. Or if I just try to say like print hi, notice that gives an error. It says hi is not defined. So it's looking for that to be defined in that case. So one of the cool things about this Python interpreter is that we can kind of use it in this interactive way to try things out, to use it as a calculator. There's a whole bunch of usefulness to be able to type something and then instantly get a response. Okay, so we're going to come back to this later on, and when we go to do stuff, it's kind of like it doesn't hurt anything if you make a mistake. It'll just tell you that it's not formatted right or you did something wrong. So don't feel worried about that you're going to type something wrong and screw something up. The shell is really just a program. You're typing things in. If the interpreter doesn't understand what you're saying, it'll give you one of these error messages. If it does, then it'll give you the result of whatever it is you typed in. And sometimes you might get a result that you don't expect, but that's kind of the point of this, is to experiment and figure out what does what and why. All right, so let's switch back to the slides here. All right, switching back to the slides. So we took a look at that. The next thing is script mode. And in script mode, essentially a script mode is where we write programs. So the idea there is rather than typing a single line, having it take an action, we're going to write out a whole bunch of lines. So maybe 10 lines or 20 or 50 or 100 or 1,000. We're going to write out a lot of lines, and then we're going to save them in a file. And then to run that, you can load it back up and then run them all at once. So it's kind of like the difference between just thinking of something and saying it like the interpreter does, having it take an action immediately, and writing down a list of instructions or sequence of instructions and then giving it to someone and say, do all of these things that I told you to do. And that's what script mode allows us to do, and that's really how programming works, is it allows us to do complicated things, or at least things that are more complicated than we could do with a single line. We can record those as a sequence of commands and then reuse them later. That also means that to reuse it later, we don't have to keep typing them out over and over again. We could just say, run this program that I saved off, and it'll do all of the things in there. So that saved sequence of Python commands is called a script or a program. And really, the word script, you can kind of think of that like a script for a play, where everything is written out, the stage directions are written out, what everybody's supposed to say is written out. You can kind of think of it like that. But really, that's also a program. A program is just this sequence of instructions that you saved off for reuse later. Okay, so script mode, it allows us to edit that text file, and that can contain multiple lines, and then we can rerun it later whenever we want to. And those programs or scripts are sequences of instructions that we can create, save, load, edit, and execute, and that's a huge advantage as well, in that we can try it, and then if it doesn't work or if it's not complete, we can load it up again later and add more features to it and try it, and then add more and try it and add more and try it. And if we have bugs, we can edit it and fix it and then try it. And so that's really the process of programming, is kind of, as we're going to learn here in a little bit, we're going to write some simple instructions, and then we're going to kind of grow that to do something more complex. And if we have a bug, we're going to fix it. But this ability to save that off in this file and then kind of reload it and edit it and change it and modify it and extend it or fix it, and then test it, is going to be integral to our creating of programs. So script mode, you can think of it a little bit like a word processor for writing programs. So rather than writing a story where you have a rough draft and then you edit it and you cut parts of it out and you make changes to the story, it's kind of like that, except in this case, the story is a program that the computer is actually going to do something with. The Python interpreter is actually going to carry out those instructions. It's like taking that idea of a story out of your head, putting it into the machine, and then having it do that. And the cool thing is we can rearrange that, copy, cut, paste, delete, insert, whatever we want, just like a word processor you would use for some sort of document you're working on. And that way we can get the program that we want. All right, so to get to script mode, the first thing we do is basically go to the file. There's a couple ways. You can either press Control-N, which is a shortcut, or you can go to the File menu and then say New Window. And just, let's try that quickly here. So I'm going to switch back over to that. Okay, so notice here, up at the top, there's this File menu. So if I say File, and I say New File, I will get this new window that will come up. And right now, notice it says Untitled. And this, unlike the script mode, or unlike the immediate mode, this actually now allows us to write a program. So in this program, for example, I could write print hello. And then I could put on another line, print. And notice it didn't do anything when I hit enter. It did absolutely nothing. It's like print, welcome to my game. Then I could do print, done. So this is the worst game ever. It allows you to make no choices and do absolutely nothing. It just says, hello, welcome to my game, and then it says done. Now, this is kind of how we're going to go about doing some programming in here, is we're going to end up starting out with something simple, and then maybe we would get this working, and then we go and add more stuff to it. So now to run this, there's a couple ways to actually execute this and try it. One of them is if we go up to run and say run module, and you'll notice there's a shortcut there too. That's F5 that shows up. So right there it says F5. So you can either hit F5 or we can say run module. Now one thing it allows us to do, it says you have to save this in order to run it. So in other words, we have to save that off in a file. And one of the things that I would suggest doing is making a folder for your work for this class in your computer somewhere, and then saving all the stuff that you write in there. And you might even subdivide that folder into the lab assignments, lab 1, lab 2, lab 3. You might make a separate folder for each of those. You might make a folder for test stuff that you're working on, but I'll leave it up to you to organize that. But one thing when you go to save these, example program 1.py, make sure to save it with that .py extension. And then notice it saved it and then ran it, said hello, welcome to my game, and then done. So notice it took all three of those actions, only run it. And if I want to run it again, then I can switch back over here and I can say run module again, it'll run it again. And we get the same result because that's all it does. But notice how easy that was without having to retype the program in. We can run it once, save it off, run it once, run it again, run it again. And so when you're actually using a commercial game, playing a commercial game or using a commercial piece of software, it's really somebody's written a program already that has a bunch of lines of code already saved off. And we can then load that up and run that to get it to do things. And that's what we're going to be doing in this class, is writing a lot of those little programs. All right, let's quickly switch back to the slides. Okay, so we know how to create that thing. We know how to, in two ways. The next thing is, once you have that blank window, like we said, you can type stuff in. Nothing will happen until we run it. We know how to save. Use File, Save, or press Control-S. Also, if you just do F5, it'll say, hey, you should save this, and you can just say yes. So once you get working on it, you don't have to really do Control-S or do File, Save every time. You can just say run module, or press F5. And then one of the other things that's probably important to think about here is that you can actually save that program and close it, and then reopen it again later. So for example, let's go back to display capture for just a second here. And let me switch back to that program window. So here's this program window. If I wanted to close that, I could go ahead and close that, and now it's gone. And if I wanted to reopen it, I could reopen that same thing. Now to reopen it, I can just say File, Open. But notice there's a really useful feature in this as well where I can go to Recent Files, and you'll notice it'll show the most recent things you've worked on in there as a list of them. And I've got a bunch of stuff in there from different things that I've worked on. But if I bring that up, I am back to now having the window open and back to able to now edit this. And to edit, I can use the arrow keys to move around. Let's say I want to change this from hello. I want to change this to Super Ninja Fighter Express. So that's now the name of my game. So now I've edited that program. I didn't have to change any of the other lines. And maybe I say, well, you know, I want to make this look a little fancier. So I'm going to like kind of decorate this a little bit. So I'm going to put like some asterisks on the side. And I say, you know what? That's still not as cool as I want it to be. So I want to add like a little, make it like a little box at the top when I run this thing. So I'm going to do another print here. And do like that. And now notice I want to finish off the bottom of the box. So rather than retyping that whole thing, notice I can just kind of highlight that and then do normal kind of editing things like you would in a word processor. So Control-C to copy, Control-V to paste. And now I have that box. And maybe I'm still not happy with that. Maybe I want it to be a little bit taller. So I'll do a Control-C on that, Control-V, Control-V. And now let me take out the stuff inside here. So notice that I'm just editing this kind of like you would a word processor program to make any kind of document. But in this case, we're writing the program. So now we have our little title bar thing at the top. And so now when we run this, so again, F5, you need to save this, okay? And there it is, and now we have that doing that. And that's kind of the workflow that we're going to be using as we work on the programs in this class. Is you're going to edit some code, you're going to try it, see what it does, you're going to go back and edit the code, try it and see what it does. And generally what I would suggest is when you get to the assignment portion of this, kind of start with something simple and small, get that working, and then evolve it. So make that a little bit closer to what you want it to do. Test that, get that working, make it a little bit bigger, and so forth. So one of the mistakes that I noticed that beginning programmers make is they a lot of times will try to type in the whole thing all at once, and then there'll be bugs all over the place and they won't know which thing is causing the problem. And that's why it's important to kind of make the program, and we're going to look a little bit at software engineering concepts a little bit later on in the course, but there's a methodology for kind of that iterative approach to development, and that there are names for those. There's formalized versions of those. We're not going to worry about that too much in this class, but just note that we are going to be writing some more complicated programs by the end of the semester, and so you're going to have to kind of plan ahead a little bit and also kind of build a little bit at a time to get those working. Okay, now let's take a look at a few other Python commands. So far, the only one we've seen and used is print, and print is like a print function that you use these parentheses, you put what you want printed in those parentheses. But let's take a look at a few other commands here. Okay, so the first one here that I'm going to mention is comments. So comments have been called by programmers and software engineers the most important command, and they do absolutely nothing. Absolutely nothing. Not one single thing do comments do when you run your code. And so why would they be important if they don't do anything? And essentially what they are is they're a way to give a note to yourself as a programmer, or a note to other programmers, or a way to mark something in the code to say to do, like a to-do list, like to do, go back and fix this later, or add the AI logic here later. So it's a way for you to communicate what you're thinking along with the code that you're actually writing. Why is that code there? What's it doing? So, for example, it starts with a pound sign and continues to the end of whatever line it's on. So if you have a pound sign at the beginning of your line of code, then the whole line becomes a comment. But if I have some code and then I have the pound sign, anything from that pound sign to the end of the line becomes a comment. And you can write whatever you want in there. You can type in things. The general idea, though, is that you're going to write notes to yourself or your future self or other developers that explain why that code is there and what it's doing. Now, I had programming teachers tell me that every line of code that you write should have a comment associated with it. And I'm going to tell you that that's kind of ridiculous. There's no reason to do that. And if you write your code well, a lot of times you won't need comments. It'd be kind of self-commenting. That the way the code is written, it kind of explains, or it's easy to understand what it's doing without that. And a good example would be this down here, this print game over. There'd be absolutely no reason to write a comment that says this prints game over, because you can tell that from the code itself. So generally what my rule of thumb is, if it's something like a formula or a calculation that's not apparent what it's doing or why it's there, or if it's a part of the code that would be confusing to you or another programmer if you came across it later without you being the one that just thought of it, then add a comment that kind of helps explain it. And that can save a whole lot of time and a whole lot of headache in the long run. The other thing to watch out for is putting comments in your code and then modifying or changing the code and then not changing the comment. And that can be worse in some cases than not having a comment. Because if your description that says this prints out welcome to the game and it actually is the game over message, then that's going to be really confusing for somebody looking at it later, because the comment is going to be out of sync with what the program's actually doing. So my rule of thumb is the comment should help with understanding in cases where it'd be hard to understand what's going on in that code. Things like complicated formulas, or even a simple formula like this is calculating the area of this because we're going to use that to calculate the damage done or something like that. So if you just had this area formula in there, then somebody would have to look at that. It looks like the formula for area, but why are we calculating the area? I don't know why. And so it should be more than what the line is doing. It should be like, why is it doing that? Okay, so comments allow you to put notes to yourself or others. The interpreter will just see that comment. It'll skip over it completely. It won't do anything with it. And in this class, you should have comments at the top of every program you write and submit. And at a minimum, they need to be the name or your name. So you wouldn't put underscores there. You'd fill in your name, the actual class and section. So this would be ETGG1801, section 51. And then what lab number it is. So for example, if you're turning in code for lab 3, you'd put 3. And some of the labs will have multiple parts. So if it's 3A, you'd put 3A. And if it's 3B, you'd put 3B. So every one of your programs should have this at the very top, the first thing in the program. And again, the interpreter is just going to skip over it, but it's going to be a way for me to know whose program it is, what class it's for, what lab it is. And that's going to be useful. So make sure when you submit a program, the first lab is not going to have you submitting programs, but make sure when you go to submit a program, you put this stuff at the top. And I will start taking off points for those if I start getting programs that are not commented properly at the top. In addition to that, you should probably have comments in things later on that anything that would be unclear to someone else looking at the code. Okay, so that's comments. And notice I used some comments down here, but the actually, I don't know why. Okay, blank lines. All right, so the null statement is another one that can be really useful. And essentially, the null statement is either a blank line, or Python has a special keyword called pass, which is kind of like, if you imagine like you're playing like a board game and it gets to be your turn, you can say pass and it'll just skip over that. So either way, what the interpreter does, it skips over all blank lines, so lines with nothing written on them, or any line where the keyword pass is the command that's on that line. And the main usefulness of the blank lines is for visually separating sections of code, like paragraphs do for writing. So in other words, If you want to say, here's a section of code that does something, and then below that, here's this other section, rather than running them right together, you can visually separate them. And then you can tell this part is just maybe calculating the damage is distinctly different than moving the character is distinctly different than killing off the player when they're dead is distinctly different. So it allows you to use kind of white space, blank lines to separate things that are in the code. Now, and you'll notice that pass keyword can be used as a placeholder. We'll see where that would be used later on. Okay, and notice here's an example. I have this blank line there. That's a null statement, so I can say game, skip a line, over. And notice I did use some comments to say the next line is blank, previous line is blank. You probably don't need that in your code, but it does allow us to separate these two lines. Now, when I print this, it's not going to make any difference in how it's printed because the interpreter is just ignoring that blank line. So in other words, we're not going to get game and then a blank line and then over. It's still going to be game with over right underneath it. Okay. A little bit more with print statements and strings. The print statement is used to display text. It can print strings, like we see here. It can print numbers, like 12 plus 6. It'll actually calculate, Python will calculate that, and then print the resulting value of 18. You can also use it to print multiple things. So here's a string score, a comma, and then 0. So it'd say score. Now, when you see a comma, it'll automatically skip a space, so you'll see score 0. And just for fun, let's go back and do that in the shell here. So as an example, I could say print score, colon, comma, 0. And notice we get that space between the colon and that. So that comma automatically puts a space between those. If I want to print out multiple numbers, I could do that too. I could say print 100, 50, 10 times that divided by 4. And you'll notice that it'll print out the results of each of those, automatically putting a space between each of them. So it'll print out the 100, skip a space, print out the 50, skip a space, print out the result of this calculation, 862.5. Okay, let's switch back to the slides for a second. Okay, now in addition to, and let me go back for just a second here. Notice that we've only so far used these double quoted strings like we have here, but there are other types of strings we can use as well. And those are the traditional double quoted ones that we've been using. And one thing to note is this, it's not a different character at the front and the end. That's just the font that's used on this, the slides here. It makes it look like this is a different character. An open quote is different than a closed quote. But in programming, in the Python shell, the double quote is always just like straight up and down lines. It's always going to look the same. So that don't worry about you have to find a different key for the open quote as the closed one. It's really the same on both ends. It's just the font that's making it look like that. Now, there are also single quoted strings, which start with a single quote and end with a single quote. And really, they do the same thing, identical behavior. There's no difference between what they do, except for one thing, that the double quoted string cannot contain double quotes inside it. And a single quoted string cannot contain single quotes inside it. And the reason for that is obvious, because the double quote means that's the end of the string. So if I tried to use a double quote inside of there, let me switch back to the shell quickly and I'll show you what I'm talking about. So for example, here we are in the shell. If I wanted to print out and say the robot said, quote, beep, boop. And you'll also notice something looks wrong because it's not in green anymore. So notice that's going to give me an error. It says invalid syntax. So I tried to print out this double quotes. That's not going to work because as soon as it comes across this double quote here, it says that's the end of that string. So if we want the double quotes, we could do the same thing that we did up here, but we could use single quotes. I'll just cut and paste that. So if I want the double quotes to show up on the screen, I could surround this in single quotes. And now it will actually print out the double quotes just fine, because single quote is ended with single, can contain double, double ends with double, can contain single. But they do the same thing. There's no other difference. Okay, switching back to the slides. All right, there's one other kind of string, which is called a triple quoted string, and it can cross multiple lines and preserve formatting, meaning that if we have something complicated we want to print out, that like instructions or something like that, and you want the formatting of it to be very precise, then we can use this triple quoted string. And what it starts with is either 3 single quotes like we have up here, quote, quote, quote. It has to end with the same 3, or it could be 3 double quotes, quote, quote, quote. But that has to start and end with the same thing. And the only rule on those is those can contain single quote and double quote characters, but cannot contain the same triple quote that has started it, because that would also end it. And that can often be easier to use than multiple print lines. So if we go back to that program we had earlier, let's just quickly switch back to that. Remember this one, this print we did up here, we could have done that with triple quoted strings. So for example, I could have said print, instead of single quoted or double quoted strings there, I could have done a triple quoted string. And then I can actually take a bunch of this off and make this just one thing, as long as I end it with a triple quoted string. And let me take all of this off. And in fact, if I wanted a blank line at the top, I could put that there. If I wanted one at the bottom, space below it, I could do that. So now notice what I did is that triple quoted string, I have now drawn this kind of picture, including the formatting inside of here. And so when I run this, F5, yes, I get this thing printed out exactly as it is. So the triple quoted strings, the advantage of that is they can span multiple lines, and it will preserve whatever formatting we have inside of there. So if I wanted to change, and I can put double quotes and single quotes inside of there as well. Okay, so back to the presentation. All right, now there's another thing that's worth mentioning here, and that is escape sequences. And escape sequences give us the ability to embed special characters into a string. And so a few that are going to end up being useful are \n, which is a new line, which says go down to the next line. So if I wanted to print game and then over underneath it, then I could put game \n over in all in one print statement without using triple quoted strings or anything like that. Without using multiple print statements, I can just use that \n. \t moves something over to the next tab stop. It can be useful for aligning things when you print them out. \double quote will print a double quote, and that could actually be inside of double quotes just fine, because what the escape sequence, the reason it's called an escape sequence is, in other words, when it's printing something and it comes across a backslash, rather than printing a backslash, it'll say, oh, this is a special character meaning that we want to insert. And the reason why they have these is it's not so easy to type, like, for example, a new line. If you hit enter, it'll go to the next line in the editor, or move stuff down in the editor. So we want to have a way to say, when we print something, have a new line or a tab instead of using spaces, or a double quote inside of a double quoted string, or a single quote. So the escape sequence allows us to insert those things. And since backslash is the thing that starts it, \backslash gives us a backslash when we print something. And there's some other ones here as well. This one is interesting, this \x and then a number, a hexadecimal number here, can give any character in the range 0 to 255, you can actually print with this. So if you wanted to print out something using its hex value, you can just do \x and then put the value of that whatever character you want, including ones that you can't easily get to on the keyboard. All right, now let's look at a quick example of using some of those escape sequences. So let's switch back once again to the Python shell. Okay, so here we are. So an example here would be like print game \n over \n loser. And when I hit enter, notice that when it comes across the backslash, this is a special character. It's the new line special character, so go to the next line. So game over loser. And like I said, there are other ones we could use as well, like the tab. I mentioned tab. Let's just try that really quickly. So game, let's change out the \n to a, let's do \t after the \n. Let's do \t. And now you notice it kind of prints going down in this diagonal. Game, and then new line, tab, over, new line, tab, tab, loser. Okay, so the main ones, let me go back just a second here, and let me do that. All right, so the main ones to be concerned with here, probably the \n is the one that's going to be used quite a bit, maybe \t, and then maybe these top or other three here of the top 5. The \a will make the bell sound when you use it in the console, like that beep noise you hear. The \b is a backspace character, but the predominant ones you're going to end up using are probably going to be \n is the most common one, followed by these other ones, those top 5 here. And here are some examples. Games \n over, just like we saw before. Here's one that's a little more complicated. Print double quote, \, double quote, \, \, double quote. So this first \, escapes that quote, which gives me a double quote, and \, is a \, so this is going to be double quote, \, is what gets printed. And here's one where you put double quotes inside of a double quoted string, but we use the \, to escape it. So this is, and then in quotes, fun for me, because the \ says treat the next thing as its special character, which in this case is the double quote character. So even though it's in double quotes, it's okay to have these as long as they're escaped like we have there. All right, one final command here is the input function, which allows us to stop the execution of the program and then wait for somebody to type something in and hit enter. And that can be used to also just stop the program and have somebody hit enter, but later on we're going to use it to get keyboard input from the user, like type in your name. You could type your name in. What's your favorite color? You could type in your favorite color. And so notice that this input command can be used to get data from the user. We're not going to use it that way right now. Right now, just think of it as when it hits that, it stops, waits for whatever gets typed on the keyboard, and then enter to get pressed before it continues on to the next line after that. And one final thing I want you to be exposed to, although we probably won't be seeing this a whole lot immediately, is this concept of a continuation line. And what a continuation line is a special character that if I place it at the end of a line, as long as it's in not side of quotes, then I can take what would normally be a really long line and spread it out over multiple lines. And the main reason for that is it can help your program be formatted a little bit more in a way that is more easily read. So if you have really long lines in your program that are, rather than visible on the screen, that they stretch off for like, I guess, multiple columns off to the side, then you can't scroll through your program and read what it does. But if you use this continuation line, you can put a whole bunch of those things together all on one, as if it were one line. And we use the \, at the end of the line. Notice not inside of double quotes, inside of any kind of quotes, just kind of by itself. And then what that tells us, the interpreter, is, hey, here's this line, but there's going to be some more. So here's some more, and there's going to be more after that. And here's some more, there's going to be more after that, and now we're done. And so now we're done, then it will take its action. And we'll see more cases where we'd like to use that later on in the class. Okay, so that's all for today. I would suggest you work on Lab 1. Lab 1, you don't really have to write a program per se, as much as just use the Python shell. to do some things. And what I want you to do is kind of get used to using that Python shell, meaning where it's got the little prompt on the side, and you type stuff in and it gives you an immediate reaction. Try getting used to using that. I'd also suggest making sure you get Python installed. And before I wrap things up completely for today, just to give you an idea of how you're going to get Python installed on your machine, let me switch back to the I'll bring up a web browser here. And let me switch over to where you can actually see what I'm doing. Okay, so notice that I'm going to just go ahead and go to python.org here. And on python.org, that's kind of the homepage for where Python lives. And what you're going to want to do is go ahead and download it. So if you go to downloads, notice that it has various different platforms. There's Windows, there's OS X, there's other platforms, which includes Linux. But what I would suggest doing is just go ahead and get the one for Windows if you're on Windows, whichever one you're on. So notice there's a button here. And if you click on that, that would download it, and then you're going to run that installer. That's going to install it. And I'm going to go ahead and cancel that since I already have it installed. But once it's installed, then to run that, you can go over here to your start window, which you, here, let me move that over and so you can see it. Oops. Move that so you can see. All right, so down here, looking at the window, if I go down to the P where Python would be, notice I've got multiple versions, but Python 3.8 is what you're going to get, and then you can run idle, which is what we've been using. You can also run this kind of 32-bit DOS version of it here. So if you click that, you'll get like a little black console window that you can do things in. Either one of those is okay, but I'd suggest just using idle. And when you run that, you'll get the Python shell that'll come up. And if you want, and what you're going to do for the lab is you're just going to type in essentially print statements in here to get it to do various things. So if I wanted to print out my name, I could type in something like that, and that's what the command line would look like. So what I would suggest you do for your lab is go ahead and type in the commands into here as if this were a calculator, or in immediate mode, get an immediate response. And then to submit that, what I would suggest doing is just copying and pasting off of this. So this might be the answer to question part 1. So you can do Control-C and then paste that into a word processing document. Microsoft Word or LibreOffice or OpenOffice or whatever you're using, and then or a text file even, and then submit that to me. Okay, so that's all for today. So everybody stay safe, work on Lab 1, make sure that you observe the due date on that, make sure you get that done. And next class, we're going to go a little bit farther and learn a few more Python commands. And we're very quickly going to start digging into where we're going to be able to start writing some games in here. We've got a little ways to go before we can do that, but within the next few weeks, we're going to be doing some graphical things and having stuff drawn on the screen and having it move around when we press keys on the keyboard. So hang in there. It might seem like we're doing some fairly low-level stuff, but the concepts we're learning now are going to be useful for later on, especially the concepts of writing a program with multiple lines. So if this is easy for you now, feel free to work ahead and play and experiment and do whatever you want in Python. But very quickly, just hang in there for right now, but just be aware that very quickly we're going to get into some more complicated stuff. Okay, so that's all for today. And I'll see you next time. Work on that lab. Make sure to get that done. So use the rest of the class time today to work on the lab. You should be able to get it done relatively quickly. All right, bye.